Okay, welcome students to section 2.4. Okay, section 2.4 is on elementary row echelon matrices and row operations. Row echelon matrices. Okay. Okay, definition. An n by n matrix is called a row echelon matrix. If it satisfies the following three conditions. Three conditions. Okay, number one, if there are any rows consisting entirely of zeros, they're grouped together at the bottom of the matrix. Okay, number two, first non-zero element in any row is a one. Okay, third rule, third part of the definition. The leading one of any row is to the right of any leading one in the row above it. Okay, an example of this okay, is the following matrix. So I have 1, 2, 3, 4, 0, 1, 5, 6, and 0, 0, 1, 7. Okay, then this is an example of a row echelon matrix. Okay, notice that the first entry in each of the rows is a 1, and the rows, each of them have successive zeros in the beginning of the row. Okay, and the more zeros you have at the beginning of the row, the further on down you are in the matrix. Okay, so the first row has a 1 at the very front. The second row has a 0 and then a 1 in the second entry. And so we get this kind of diagonal of 1s. And that's what creates the row echelon matrix, is that diagonal ones and then all the zeros, the triangle of zeros below the diagonal ones. Okay, let's look at another definition. Okay, the number of non-zero rows in any row echelon matrix is called a rank, or is called its rank. Okay. The rank of the matrix of the matrix A is denoted as rank A, and A is in parentheses. Cool. So let's look at an example of rank. Okay, A is equal to 1, -1, 2, 3, 0, 1, -1, -3, 0, 0, 0, 0. Okay, and so how many non-zero rows do I have? Well, I only have one row of zeros, and there are 3 rows in my matrix. So this has rank 2. Okay, so 3 minus 1 is 2. Okay, so that has rank 2. Or sorry, rank A of 2. Rank of A is equal to 2. Okay, definition. A row echelon matrix is considered reduced row echelon if any column that contains a leading one has zeros everywhere else in that column. Okay, let's do an example of a reduced row echelon matrix. There you go. A reduced row echelon matrix. Okay, if I have, say, the matrix 1, 0, 0, 2, 0, 1, 0, 3, and 0, 0, 1, 4, this is reduced row echelon. And if we were solving for a system of equations, this this form would give me the solutions to that system of equations. Okay, and we'll cover that a little bit later. But if I augmented this matrix, you would see that my first variable would be equal to 2, my second variable would be equal to 3, and my third variable would be equal to 4. Okay, well, that's kind of the goal of where we're headed with this stuff. Okay, so kind of be able to solve the some systems with these matrices. Okay, let's talk about elementary row operations. Okay, or what they call ERO, elementary row operations. Okay, there are three operations, okay, that we can do for any within a matrix. Okay, the first thing is that we can permute or swap, okay, any two rows. Okay, the second is that we can multiply a row by a constant. And three is that we can add any two rows together. Okay. Some notation that we're going to use for this text. Okay, it's not necessarily standard notation, but it's the one that this author chooses to use. Okay, and that we'll be using for the rest of the text is that if I want to permute row I and row J, I want to swap those two. Okay, we'll say that that's P sub ij. Okay, so this is the notation that we'll use. So P sub I sub j means that I'm swapping row I with row j and vice versa, row j with row I. Okay. B. Okay. If we multiply row I by a constant, say multiply row I by 5, that would be M I, and then we would put in parentheses 5. Okay, we'd say, oh, row 2 is going to get multiplied by 5, so it's M2, M sub 2, and then multiply by 5. Okay. Okay, if we want to multiply and then add, we're going to combine those two elementary row operations together. And we're going to multiply a row, add it to another row, and then replace that row. Okay. So we're going to put row operation C here is multiply. Okay. Row I by a constant, we'll just call it 5 in this case, and add to row J. And we want to replace row J. Replacing row J with the new row. Okay, and that we're going to call A ij. So we're going to take row I, multiply it by a constant, say in this case 5, add it to row J, and then replace row J. Okay, and with these three row operations, we can basically do anything that we want inside a matrix. Okay, maybe some of you are saying, well, how do you subtract two rows, right? Well, that would just be multiplying row I by a negative value or a -1, and then adding that to row J, and that would be row J minus row I. Okay, or you do vice versa. You could say, well, I'm going to multiply row J by a -1, and then add that to row I, and that's row I minus row J. So that's how you do subtraction. If you want to do division, you just multiply a row through by a fraction. Okay, Like if I wanted to divide by a row by 5, I would just multiply the row by 1/5. Okay. Okay, with these elementary row operations, we can then take matrix and put it into row echelon form. So let's look at that. Write the following matrix in row echelon form and find its rank. Okay. The following matrix in row echelon form and find its rank. Okay, let's look at our matrix. We have 2, 1, -1, 3, 1, -1, 2, and 1, -4, 6, -7, 1, 2, 0, 1, and 3. Okay, the first thing I want to do is, the goal here is to get ones along the diagonal and then zeros below those ones. So since the goal is to get ones along the diagonal, I already have a row that starts with a 1, and so I'm going to permute or swap rows 1 and 2 to make the row that has a 1 in the first row, first column entry. I'm going to swap those 2 rows to make that have that position. Okay, so I'm going to use the notation little wavy bar. Sometimes it means similar in mathematics. And I'm going to say that it's similar, okay, with row operation permutation 1 to 2. And so all I'm doing is I'm just swapping those 2 rows. And so I'm going to go 1, -1, 2, 1, 2, 1, -1, 3, -4, 6, -7, 1, and 2, 1, or sorry, 2, 0, 1, 3. Okay. Okay, the next thing that I want to do is I want to get rid of, I want to make one of the entries or elements of the first column a 0. Okay. So what I can do is I can get this entry here, the row 2 first column entry, I can get that as 0 if I multiply the top row by -2 and then add it to the second row. And that will cancel out that 2 in that first second row first column entry, because I'd end up with a 0 there. I'd get that -2 that I multiplied through the first row by, canceling with the +2, and that would cancel out those that value, and I would end up with a 0 there, and that's good. That's the goal. Okay, so we're going to say that our next row operation, our next elementary row operation is going to be A12, and I'm going to multiply row 1 by -2. Okay, because I really want to subtract the 1 and the 2, or the 2, make the 1 a 2 and subtract it. So I'm just going to multiply the first row by a negative. So -2. Now, I'm just going to put these values above the row in the first matrix. I'm not going to waste a space creating another matrix just to multiply a row. So what I'm going to do is I'm going to use the fact that I already have the existing matrix. The row is the top row that I'm working with, and so I'm just going to put these values above that top row. I'm going to go -2, 2. This would be -4 and -2. And I'm going to take these values now and I'm going to add them to row 2 and put the resultant row in position row 2. Replacing row 2 with that resultant row when we add these two together. I want the sum of this new row that I created. I want the sum of that with row 2, and that will give me my resultant row of values. And the -2 and the +2, when I add those together, they're going to cancel out and become 0. Okay, now the first row, it's unaffected. We don't replace the first row with this. I'll call it an auxiliary row. This substitute row that we created. We don't replace the first row with that. The first row remains the same. So the first row is going to remain the same. That's 1, -1, 2, and 1. And now we're going to add the 2 times -2 times the first row, what we got that with the second row. Then we're going to add those two together. That's going to give me the 0 that I want, that desired 0 in that first column. And then we're going to just add the rest of the elements, sum them up. So 2 plus 1 is 3. -4 and -1 is -5. And then -2 and 3 is 1. Okay. And so, and in order to get zeros all the way down that first column, we're going to do this 2 more times, 1 for row 3 and 1 for row 4. So this is a -4, 6, -7, 1, and then we get a 2, 0, 1, 3. Okay. Okay, so the next thing would be to use that first row and multiply through to get a 0 in the third row. You get a 0 in this first column, third row entry there. So what would I need to multiply my first row by in order to get, when I multiply the first row and then add to the third, to get a 0 in that third row first column entry? Well, it'd be 4, because I already have a -4. If I multiply the first row by 4 and then add it to the -4, they cancel out, give me my desired 0. So what would be the notation that I would use here? Yeah, it'd be A 1, 3. I'm taking row 1, multiplying row 1 by what value? 4, and then adding that to row 3. Okay, so let's do that. Multiply row 4 now by, or sorry, not row 4, row 1 by 4, and I'm going to put that auxiliary row, okay, that we get by multiplying above the first row in the matrix. So we're going to go 4, -4, 8, and 4. Okay, and now we're going to add that to row 3, and that will give me my desired result. So let's put in the rows 1, -1, 2, 1, 0, 3, -5, 1, and then the fourth row is unaffected. So plug in the unaffected rows first, and now let's plug in our third row, which is what we want our resultant row to be. 4 plus -4, that's 0. Okay, that's that desired 0 that I want. And then -4 and 6, that's going to be 2. 8 and -7 is 1, and 4 and 1 is 5. Okay. Okay, next is we want to get our last zero in the first column. We want that column to be just ones and zeros. Okay, and so what are we going to multiply the top row by to cancel out this value of 2 in the fourth row, first column position? Yeah, that's right. We want to cancel out a negative. We want to get a -2 and cancel that with a +2. So we're going to multiply the first row through by -2, add that to the fourth row, and it's going to give me my desired 0 in that fourth row, first column position. So that's going to be, oops, go back to my pen. That's going to be A14 -2. Okay. So let's put our auxiliary row above. So if I do -2, that's -2, 2, -4, and 2. -2, I should say. Okay, and add that to our fourth row. Okay, let's plug in our first 3 rows because they are unaffected. 1, -1, 2, 1, 0, 3, -5, 1, 0, 2, 1, 5. Okay, and then the fourth row is going to give me my desired 0. 2 plus 0 is 2. -4 and 1 is -3. And -2 and 3 is 1. Okay, so we worked on that first column, which is great. Okay, so now we want to get a 1 in the second column. So how could I get a 1 in the second column and zeros everywhere else? Okay. Well, I could, let's work on the 1 first. We'd like to get the 1 in this position right there. Okay, that's where I'd like to get my 1. So if I multiply row 3 by -2, and then I add that to, or sorry, by -1, I should say, and add that to row 2, then that's going to give me 3 plus -2, which is my 1. Let's do that. Let's go A. Now I'm going to multiply row 3 by -1. So that's going to be A3, and then I'm going to replace row 2 when I add those 2 rows together. So A3, 2, and then the value that I'm wanting to multiply by is -1. Let's do that. So I'm going to go 1, -1, 2, 1. I'll skip, I'll skip the second row because that's the one I'm working on. And then 0, 2, 1, 5, and 0, 2, -3, 1. Okay, so now for that second row that I want to plug in. Okay, let's multiply row 3 by -1. And where am I going to do that? I'm going to squeeze that in right here. I'm going to say that -1, I'm going to negate this third row. And so I'm just going to put a negative sign in front of all these values there. Okay, and then I'm going to add. So my resultant row is going to be 0. Okay, and the reason I work with the second and third rows is because they have zeros in their first element. Each of their first elements has a 0. And so if I add 2 rows that have a 0 together, those elements are unaffected. Okay, I can multiply numbers through any row that has a 0 in it, and it's always going to be 0, and so I don't have to worry about you know, messing up the zeros in the first column. Okay, if I tried to get rid of or try to get a 1 in the second row, second column entry, and I use the first row that doesn't contain a leading 0, then I would end up with some value that contains either a 1 or some other value, but a multiple of 1. And then I'd end up having to do more operations, so it would make it a lot messier. So to keep it straightforward and simple, I would just work with the rows that have leading zeros to not have to create extra work for us at the end. Okay, so 3 plus -2 is 1. That's my desired 1 right there. Okay, and then I have -5 and -1 is -6. Okay, and then 1 and -5 is -4. Okay, so now what do we want to do for our next elementary row operation? Okay, we have a couple of choices. We could go for a 0, get some zeros, which would be good. And so which zeros do we want to focus on? Well, I'd like to focus on that lower triangle of zeros, right? Okay, that's kind of the goal here. And so we have our ones, we have our leading 1 in our first row. We now have our leading 1 in our second row, but we don't have a leading 1 we do have a 1 along the diagonal, but it's not the leading element. We have this 2 here that we'd really like to make a 0. Okay, so how can we make that 2 a 0? Well, if I multiply row 2 by -2 and then add that to row 3, that's going to get rid of that element there, which is our desired result. Let's go ahead and do that. So we have 1, -1, 2, 1. Okay, and we want to multiply. Oops, let me put the designation here first. We want to multiply row 2 by -2. So A2 -2, and then we're going to replace that with row 3. So now the matrix that we're going to get is 1, -1, 2, 1, and then 0, 3. Oh, sorry, not 3. 0, 1, -6, -4, and then we'll skip the third row because that's the one we're working on. The last row is 0, 2, -3, 1. And so now I'm going to take -2 times the second row, -2 times the second row, and I'll put that in black. And I'm going to put these values right above the values of the second row. Okay, after I multiply by -2. So I'm going to get a 0 that stays. I'm going to get a -2. I'm going to get a positive 12. And then I'm going to get a positive 8. So I want to combine these each with the row below it. Okay, the 0 combined with the 0 is just 0. So I get my resultant row is 0. -2 and 2 is 0. Okay. 12 and 1 is 13. Okay, 8 and 5 is 13. It's interesting. Got a couple of 13s there. Okay. And so we got that zero there, that desired zero. Okay. Okay, let's go for the next zero below the one. Okay. Um, so let's go for a zero in the second or fourth row, second column. So fourth row, second column, I want to get that to be a zero. Okay, because I really want that lower triangular matrix. Or sorry, we want the upper triangular matrix is what we want. Okay. Let me just make sure that's correct. We want, is it a lower triangular matrix or upper triangular matrix? It is a lower triangular matrix, yes. Okay, so I was right the first time. Okay, see, there you go. Never second guess yourself, I guess. I'm just kidding. Okay, so it's a lower triangular matrix. Okay, and so we want it to have all zeros in the bottom of the matrix. And so we're going to get rid of that 2 that's highlighted there. So once again, what are we going to do to get rid of a 2? We're going to multiply the second row by -2, add that to the fourth row, and cancel out that element. So let's go ahead and do that. Okay, so once again, I can multiply my, let's do the notation here, A of row 2, but now we have 4. Row 4 is the one that's being affected, and then we have the value -2 that we're multiplying by. Okay, and so again, I'm going to put the values above the second row after I multiply. Okay, and it's the same result. So I should end up with 0, -2, +12, and +8 once again. But instead of adding them to row 3, I'm just adding them to row 4 this time. Okay, and so we get our resultant matrix of 1, -1, 2, 1, a 0, 1, -6, -4, 0, 0, 13, 13. And then the resultant row of 0, 0, -2 and 2 will cancel. Okay, to become 0. 12 and -3, that's a 9. Okay, so that's a 9. And 8 and 1, that's another 9. Okay, that's kind of cool. Okay. Okay, so now what I want to do is let's work on getting 1s along the diagonal. So I'm going to say that I'm going to multiply row, back to red. I'm going to multiply row 3 by 1/13. So multiply row 3 by 1/13. Okay, and that essentially is just dividing that row by 13. Okay, and since I have 2 13s, I end up with 1. Okay, so just 1's there, which is nice. So that resultant matrix, oh, there we go. Okay, is going to be 1, -1, 2, 1, 0, 1, -6, -4, 0, 0, 0, 1, 1. And then I have 0, 0, 9, 9. Okay. Okay. I'd like to get this element, now that we have a 1 here, a 1 here, a 1 here. I'd like to get this element to be a 0. Okay, so how can we get that guy to be a 0? Well, the last two rows contained 0, 0011 and 0099. I would like the fact that all of these are zeros, because if I add zeros together, again, I get 0, and I don't have to worry about messing up the characteristic of those rows. Okay, so I'm just going to work with the last two rows here to get rid of this 9 that's kind of messing things up. We want a 0 below the 1. Okay, again, going back to the definition, okay, of row echelon, it says the number of non-zero rows in any row echelon matrix. I don't know, that's a rank. It's that there are any rows consisting entirely of zeros. They're grouped together at the bottom. The first non-zero element of any row is a 1, and the leading one of any row is to the right of any leading 1 in the row above it. Okay, and so as we go and look at these diagonals, okay, the leading 1 in each of these can only be a leading 1 because it has zeros in front of it. Okay, that's what makes it a leading 1. And each of them, the row below, is one element to the right. Each of the elements that are 1s here are always one element to the right, and they're right below each. And so in order for the last row to have an element of 1 eventually along the diagonal, we need to get rid of the leading elements and make them all zeros. Well, let's get rid of that 9. Okay, so what are we going to do to remove that 9 and make it a 0? Yeah, we're going to multiply row 3 by -9 and then add that to 9. So multiply row 3 by -9 and then add that to row 4. And then we can get rid of that, that leading 9 there and turn it into a 0, which is the goal. So if I multiply through by -9, I would get -9, -9. And then I could add that, and lo and behold, actually both of those become 0 in our last row. That's kind of cool. Okay, so this becomes 1, -1, 2, 1, 0, 1, -6. That's a -4, right? -4, 0, 0, 1, 1, and 0, 0, 0, 0. So we do get a row of zeros. Okay, so this guy is now row echelon form. This is in row echelon form. It has the diagonals of zeros. That makes it our lower triangular matrix. And we end up with 1s along the diagonal. Now the last row doesn't have a 1 along the diagonal because it's a 0. It's a row of zeros. Okay, which makes this have rank what? Well, how many non-zero rows are there? Yeah, it has rank 3. Okay, there are 3 non-zero rows because the last row was a row of complete zeros. Okay, we're going to continue on with this matrix. Okay, and we're just going to call number 2 here, example 2, to turn this row echelon matrix into a reduced row echelon matrix, which means that we want all of the rows that have leading 1s to only have zeros everywhere else. So let's write our row echelon matrix And then with just 1, 2, 3 steps, we can turn this into a reduced row echelon matrix. And if it was a system of equations, we could get our solutions to that. This would be what's called a dependent system because it has a row of zeros, and we'll get to all that later on. Okay, that's the kind of the crux of the course. Okay, so let's start with the result that we got in example 1 and make that our starting point, our jumping off point for example 2. We've got 1, -1, 2, 1, 0, 1, -6, -4, 0, 0, 0, 0, 1, 1, and then 0, 0, 0, 0. Okay, so how can I make this element in the row 1 second column entry, how can I make that a 0? Well, if I just add that to row 2, that resulting row will contain a 0. So that's kind of cool. So the row operation that I want to do is just A1, nope, A2, 1. I want to multiply row 2 by 1, and then add that to row 1, replacing row 1. Okay. Okay. So when we do that, we're going to get row 1 to be replaced as -1 and 1 is 0, 1, 0, -6 and 2, add these two together and those two together, we get -4, -4 and 1 is -3. Okay. And then we get a 0, 1, -6, -4, 0, 0, 1, 1, and 0, 0, 0, 0. Okay, so that's good. So the first column, we're locked in. That has all ones and zeros. The second column is nice. We're kind of locked in with the second column now that has all ones and zeros. The third column, that needs a little bit more work. Okay, we have our diagonal of ones from our row echelon form right there. But in our third column, we don't have zeros. We have -4 and -6. So we need to make those zeros. So what I'm going to do is I'm going to use row 3 here. Because again, I like adding zeros to things because it doesn't affect the result of the other columns, the values in the other columns. So I'm gonna look at that 1 there in the third row, and I'm gonna multiply that by a +4 to get rid of the -4 in the first row, and then subsequently in the next step, I would multiply by that row by a 6 to get rid of the -6 in the second row. So let's work on the first row first. So we're gonna try to get rid of this element here using that third row. Okay, so we're gonna say that the notation is that we're going to multiply row 3 by 4 and replace row 1. So that's A3, 1, 4. Okay, A3 run, multiply row 3 by 4, and then replace row 1. Let's go ahead and do that. Okay, if I multiply row 3 by 4, I just get these values here. That would just be 4 and 4. And then I would add that to row 1, and I would get 1, 0, 0, 1. That's kind of nice. 1, 0, 0. Okay, okay, good. I like that. Okay, and then the second row is unaffected at this step. 0, 1, -6, and -4. My fours are looking like nines right now. Okay, -4, and then 0, 0, 1, 1, and then 0, 0, 0, 0. Okay, and we're almost at the end here. We're basically on our last step. We're going to do the same thing here. We're going to use row 3 to get rid of that -6 entry right here, so I can get my third column to have all ones and zeros. Okay, I'll basically have 1, 1, and then the rest of the column zeros. And so multiply, you guessed it, row 3 by 6, and then add that to row 2. So the designation of the notation is going to be multiply row 3 by 6, and then add that to row 2. Okay, so there's the notation for that. And if we multiply this by 6, just put those values. I remember when I was playing Sudoku a while ago, I always put these little values in the corner to kind of test if those were possible values for Sudoku. This reminds me of that, putting these little values in the corner to give me my auxiliary rows. And then I'm going to add those two to the row above, and the zeros in front of that row, they don't affect it. So we're going to go 0, 1, 0, 0, 1, and then 0, 1, 0, 2, 0, 0, 1, 1, and 0, 0, 0, 0. And that is that's the reduced row echelon form. Okay, and that is the result of that matrix. So what did it look like in the very beginning? What it looked like in the very beginning was this guy: 2, 1, -1, 3, 1, -1, 2, 1, -4, 6, -7, 1, 2, 0, 1, 3. And at the very end, okay, was 1, 0, 0, 1, 0, 1, 0, 2, 0, 0, 1, 1, and 0, 0, 0, 0. That's the reduced row echelon form. This is reduced row echelon form. Okay. Okay, and that's it for section 2, 4. I will see you guys in the next section.